Hi, greeting to all. We are from Shopee, the leading e-commerce platform in Southeast Asia and Taiwan. In this video, we're pleased to present our paper named Trigger-Relevancy and Diversity Inefficiency with Dual-Phase Synergistic Attention in Shopee Recommendation Ads System. The agenda for today will be firstly, an introduction to the concept of Trigger-Induced Recommendation, or in short, TIR. Broadly speaking, we could roughly categorize all recommendation scenarios in the industry into exploratory recommendation and trigger-induced recommendation. Exploratory recommendations are mainly recommending based on users' historical interests and items' popularity among the community. Some classic examples include the homepage recommendations on YouTube and Amazon, as well as the Explore tab on TikTok and Instagram. Trigger-induced recommendations, on the other hand, has a special trigger item that will induce the recommendation results. The purpose of TIR scenarios in the industry is to allow users to conveniently discover similar or complementary items. Items that are not related to the trigger item, but potentially interesting, will be supplemented in the recommended list too. Examples include product page you may also like on e-commerce platforms such as Shopee and Amazon, or the up next recommendations on YouTube while one is watching a video. In TIR scenarios, the coexistence of related and non-related recommendations with respect to the trigger item leads to the inefficiency problem we identified in this work. We named the inefficiency problem as Trigger Relevancy and Diversity Inefficiency, or in short, TRDI. To our best knowledge, there is no prior studies on such inefficiency in TIR scenarios. In this session, we present our method used to measure the extent of TRDI in our system. Well, before we dive into TRDI, let's understand these two simple terms, trigger relevancy and trigger diversity. Here's an example. A user searches for cat scratchboard and clicks on one of the search results and enters the product detail page. The scratchboard for cats falls under the category of cat accessories. The user then scrolls down the page and triggers the You May Also Like recommendation session. The orange and yellow boxes are either similar or complementary items, sharing the same category as the trigger item. In our work, we label such recommended items as trigger-relevant items. The blue box, on the other hand, contains an utensil holder, which is not for cats, and such unrelated recommendations are still displayed in TIR scenarios because the user has expressed interest for similar items in past sessions, and we label such recommended items as trigger-diverse items, as they do not share the same category with the trigger item. With understanding on these two terms, we conducted analysis to assess Shopee users' preference on trigger relevancy and trigger diversity in Shopee's You May Also Like recommendation scenario. And the basis of our analysis is as follows. We first define an R-score, which is the ratio of the CTR of trigger relevant recommendations to that of trigger diverse recommendations. Well, intuitively, if the R-score is greater than 1, the user prefers trigger relevancy, indicating that trigger diverse items are being recommended more than necessary, which implies inefficiency in the system, and vice versa when R-score is smaller than 1. And here is the plot of the distribution of R-scores across Shopee's individual users. Ideally, we hope to see that the R-score distribution concentrates around the value 1, indicating that our system has efficiently satisfied the user's preference on both trigger relevancy and trigger diversity. However, we are seeing majority of them deviates from 1 instead, and such deviation indicates inefficiency in traffic allocation on the user individual level. But the analysis fails to differentiate among different categories of trigger items. Thus, let's break down the analysis for specific categories of trigger items. On the right-hand side, we have the R-score distribution when the trigger item belongs to category 203 and 65. From the plots, we have two observations. Firstly, the distribution varies across categories of trigger item. And the left plot shows that when trigger item belongs to category 203, trigger diverse items are generally more popular. And the second observation is that even within the same category, R score still deviates from 1, but the extent of deviation differs across different categories of trigger items. And both these observations indicate inefficiency when allocating recommendations traffic for different categories of trigger items. Or more simply, a user may prefer trigger relevancy when viewing one category of trigger item, but he may prefer trigger diversity instead when viewing another category. And this is the trigger item level inefficiency. As we now understand, recommendations in TRDI scenarios are suffering from the two levels of inefficiency we have pinpointed earlier. So we propose a novel model architecture named dual-phase synergistic attention, in short, DPSA, to tackle each level of inefficiency. Next up, we will share our method from a high-level perspective, and we may omit some details, but you can find all those details in our paper. And the diagram here illustrates the structure of our proposed method, DPSA. The basis of DPSA is this trigger item sequence. So let's first understand what trigger item sequence is. Unlike the usual behavior sequence, the trigger item sequence records trigger items that have received clicks in the follow-up induced recommendations. Therefore, the trigger item sequence will have a one-to-one mapping relation with the click item sequence as illustrated in the diagram. With understanding of trigger item sequence, let me introduce the first phase of DPSA, which aims to tackle the individual level of TRDI. Well, this phase is quite straightforward. We compute the relevance factor of the trigger item sequence and the click item sequence for each time step. And if we think about it, each relevance factor intuitively represents the user's preference for trigger relevancy or diversity at each time step. And the relevance factors are then combined and transformed into a score of factor via a feed-forward network. And this relevance signal computed represents a user's general preference for trigger relevancy, and therefore helps to efficiently personalize the trigger-induced recommendation results for the users. Implementation-wise, this is quite similar to the additive attention mechanism used in the famous deep interest network structure, and therefore this is the first phase of attention. In the second phase, we construct the enhanced click item sequence to strengthen the model's understanding of users' differing propensity to trigger diversity across categories of trigger items, and therefore it helps to tackle the trigger item level inefficiency in the system. We take the current trigger item as the query, and the trigger item sequence as the key, and then we compute an intermediate representation from the two inputs. The header mark product of this intermediate representation and the click item sequence gives a weighted click item sequence, which is the enhanced click item sequence. And intuitively, the intermediate representation is the similarity between the current trigger item and the past trigger items. So semantically, if a past trigger item A is similar to current trigger item, then a user may have a higher likelihood to give positive feedbacks on recommended items that is similar to the items clicked with the past trigger item A. After obtaining the enhanced click sequence, we pass it as key and value into an attention unit, be it multi-head attention or transformer, any typical attention unit, and it will produce output 2. And here, both output 1 and output 2 can be easily combined and fused with outputs of other modules like DPFM or MMOE, therefore making DPSA a plugin-like module that can be easily adopted by any base model. Well, next, let's take a look at the actual effects of DPSA on Shopee's business. In offline, we use the same datasets to train 4 different CTR ranking models, so as to fairly test the performance of each phase of DPSA. We found that the complete version of DPSA is the best performing one, with 0.3% of relative improvement in offline AUC. It is important to note that an advertising system is a seesaw game involving user, seller, and platform, each with different objectives to fulfill. And the user's experience could be gauged with CTR and CTCPR. The seller's interest could be measured with CTCPR and GMV, while the platform's primary goal is to maximize revenues with minimum damage on user experience and seller interest. But our model is only trained to optimize CTR, and therefore we conduct a rigorous online A/B test involving billions of item impressions to ensure significance of our results, as well as to ensure the impact on key business metrics that are not optimized by our models. And the online results are quite impressive with significant improvements on all key business metrics. Besides, we also conducted a post-analysis on experiment traffic logs for one of our regional markets. We found that the impression of trigger relevant items increased while that of trigger diverse dropped. Yet, the CTR of both increased significantly. And this clearly indicates that the users in this region has been recommended too many trigger diverse items in the base group. And in a nutshell, our main contributions are as follows. Firstly, we identified TRDI problem for the TIR scenarios, and we shared a systematic approach for the community to conduct similar analysis to gauge the extent of TRDI in their TIR scenarios. Secondly, we proposed DPSA to tackle TRDI, and we believe DPSA is generalizable to other industry TIR scenarios, and DPSA's plugin-like trait allows it to be easily adopted by any base model. Nonetheless, we have to admit that as there's no publicly available TIR benchmark dataset, and our company's confidentiality policy prohibits us from sharing our internal datasets, our reported performance therefore may lack external validation. But with the method we shared, we hope that the community can quantify the extent of TRDI problem in their businesses, thereby attracting more targeted optimization efforts for TIR scenarios as a whole. And with that, we have come to the end of our presentation. Thank you.